talk about the Falling Apple Science Institute's way of teaching the moon cycle. Now, this is something that every elementary school student learns, and yet it doesn't stick. And this has been shown by interviewing college students about whether they can identify see where the moon is and predict where it's going to be 2 or 3 days from now. And the result is that the vast majority of college-educated people don't understand the basic pattern of the moon cycle and can't even predict where the moon is going to be next week. Now, why does this happen? Well, it's because the subject is taught in an unnecessarily complicated theoretical way. The moon cycle is usually shown to students from an outer space perspective, with the moon orbiting the Earth and the Earth orbiting the sun, and then the student is supposed to translate from that to what he sees on Earth, which is a complicated process, and nobody does it very well. And so the student never understands what he actually sees in the sky. Here's a simple way to understand what you can see in the sky. And let's start with what we call a new moon, which is when the moon is right near the sun. Okay, this is when we don't see the moon at all. And the moon travels around on the same path as the sun in a new moon. But it travels a little slower. 24 hours it takes the sun to go around. The moon takes almost 25 hours. So it falls behind the sun by almost an hour a day. So after a day, we're going to see a thin crescent moon. Just behind the sun. And every day the moon falls an hour back. And as it does so, its phase changes, of course. And by the time it's fallen a quarter circle back from the sun, we see a half moon in the sky. Okay, so here I have the sun in the summer solstice position, where we would where we see it at the time of year I'm talking. So the waxing quarter moon is going to be in the at the spring equinox position. Okay, so it's actually going to be above the horizon for 12 hours and below it for 12 hours, and we're going to see a half moon. But it continues to fall back behind the sun by about an hour each day, and eventually, after a couple of weeks, it's a full moon. Now notice something interesting here, and I remember first noticing this years and years ago, before I even really understood the moon cycle clearly. I had a master's degree in physics and still didn't quite understand the moon cycle, like most people. But I had noticed in the summertime that the full moon was strangely low in the sky. Well, the horizon globe shows you exactly why. The full moon is approximately on the ecliptic, but it has to be opposite in the sky from the sun. So it has to be on the winter solstice position of the ecliptic, which means it takes the low path across the sky when the sun takes the high path. Okay, so this is exactly, as I speak right now, we're coming up to a new moon, but in a few weeks we'll have a full moon in early July, and people will see that full moon take this low path across the sky. Now, every day it continues to fall an hour behind the sun. So after 3 weeks, it's going to be in the spring equinox position. So we're going to be back to having the moon above the horizon for 12 hours and below the horizon for 12 hours. And then in another week, it continues to fall back toward the sun. There we go. And we'll have a waning crescent moon right before it reaches the sun, and the cycle starts again. But once you catch on to this basic pattern, it's actually fun to keep track of the moon. You know exactly where it's going to be in the sky at all times. And you can follow it day to day and know exactly how the phase is going to change. You always know where to look for it. The pattern is very simple, basically falling. The sun is our basic timekeeper, and based on the time of day, you always know where the sun is. The moon does the exact same thing as the sun, except slower. Almost an hour slower each day. So you just see it falling behind the sun and its phase changing accordingly. So it's the simplest thing in the world, and it's embarrassing that educated people don't know this, but it's certainly not their fault. It's not taught very well. If you're taught it in terms of a theory, and then you're asked to do this complicated geometric translation from an outer space view to what we see on Earth, it's unnecessarily complicated, and people never get it. But it's actually very easy to show with the horizon globe, and you not only do you see the changes in position between the sun and the moon on its monthly cycle, but you see why the moon changes in altitude the way it does with the seasons, as the sun does.